It began with a rupture, a fissure in the earth, sudden and immense, a dramatic tear in the planet's surface. The scale of this event was truly awe-inspiring. In 2005, in Ethiopia's Afar region, a place already known for its harsh beauty and geological activity, something extraordinary happened. The ground tore open with violent force, a crack 35 miles long appearing in days, a stark line etched across the desert landscape. It was a geological phenomenon of unprecedented speed and magnitude. This wasn't just a local earthquake, a minor tremor that fades from memory. It was a profound wound on the face of a continent, a sign of immense forces at play deep within the earth. For those living there, in the shadow of this geological upheaval, it was a terrifying reminder that the ground beneath us is not as solid as it seems, that the very foundations of our world are in constant flux. Earthquakes, tremors that reverberated through the region, and volcanic eruptions followed, spewing molten rock and ash into the sky. It was as if the planet itself was groaning and preparing for change, a dramatic shift in the Earth's tectonic plates. This gash in the desert is more than a curiosity, more than just a scar on the landscape. It's a birth announcement, a sign of something new being born. Africa, the cradle of humanity, is splitting into two, slowly but surely. It's a process that will eventually create a new ocean, a vast body of water separating the continent. We are witnessing in real time an extraordinary event. A planetary event that usually unfolds over millions of years is happening before our very eyes, a compressed geological timescale. The science behind this is as grand as the spectacle, a complex interplay of forces. The Earth's crust is a mosaic of tectonic plates, massive pieces of the Earth's lithosphere, always in motion, grinding against each other. The African continent sits on one plate, a vast and ancient landmass. But deep beneath its eastern edge, forces are pulling it apart, stretching and thinning the crust. The 2005 fissure was a dramatic sign, a clear indication of the immense pressure building up, that the tension had reached a breaking point, that the Earth could no longer contain the forces within. Revealing the future geography of our world, a glimpse into a dramatically altered landscape. The East African Rift Valley has become a natural laboratory, a living experiment in continental division, drawing scientists from around the globe, eager to study this unique geological phenomenon. By studying this rift, we're not just learning about Africa's future, about the formation of a new ocean. We're uncovering how all continents have formed and broken apart throughout Earth's history, gaining insights into the planet's dynamic processes. We are watching our planet reshape itself, witnessing the slow, powerful forces that sculpt our world. One crack at a time, one eruption at a time, one earthquake at a time. It's a story of destruction, of the Earth tearing itself apart, but also of creation, of new landscapes and new possibilities emerging from the chaos. To truly understand the profound transformation underway in Africa, we need to zoom out, way out, beyond the confines of our immediate perspective. From the vast expanse of space, the continents appear as solid, fixed land masses, seemingly immutable. But this is an illusion. In reality, they're adrift, floating on a sea of semi-molten rock, a dynamic layer beneath our feet. This phenomenon is known as plate tectonics. The Earth's outer shell, the lithosphere, is not a single unbroken piece, but rather, it's fractured into giant interlocking plates. These massive plates are in constant motion, albeit incredibly slow, gliding atop the viscous mantle below. These plates interact in a powerful, albeit slow-motion ballet, a dance of immense forces shaping our world, colliding with each other, grinding against one another, and pulling apart in a slow, relentless process. Where plates collide head-on, immense pressure builds, forcing the crust upwards, creating towering mountains and often triggering volcanic eruptions. Conversely, where they pull apart, molten rock rises from the depths, solidifying and forming new crust, adding to the Earth's surface. The driving force, the engine behind this intricate dance, is the immense heat emanating from the Earth's core, fueling powerful convection currents within the mantle, the layer between the core and the crust. These currents act like a conveyor belt, slowly but surely dragging the plates across the Earth's surface, moving continents at roughly the same speed your fingernails grow. Over vast stretches of geological time, millions upon millions of years, this process fundamentally rearranges the face of the planet, shaping coastlines and creating new landforms. Africa sits upon the massive African plate, a colossal slab of the Earth's crust that was once considered remarkably stable. But the dramatic landscape of the East African Rift Valley reveals a fundamental weakness, a zone of geological instability. It's a place where the Earth's crust is being stretched and thinned, subjected to immense tensional forces. The same forces that typically operate along plate boundaries are now actively tearing Africa apart from within, creating a vast network of fractures and faults. The African plate is no longer a monolithic entity. It's beginning to fracture and fragment under these immense pressures. The continent is not merely drifting across the globe, it's actively breaking apart, a process with profound implications for the future. This internal rift is not an isolated event, it's the initial step in a long and complex geological process, a process that, throughout Earth's history, has been responsible for tearing apart vast land masses and giving rise to new oceans. We are, in essence, witnessing the very early stages of the birth of a new ocean, a dramatic reshaping of the African continent. The unfolding story of Africa's split is not just a regional phenomenon, it's a powerful reminder of our planet's restless heart, a testament to the dynamic forces that continue to shape our world. Let's zoom into the Afar Triangle, a truly unique and dynamic region on our planet. It's a geological crossroads situated in the Horn of Africa, specifically within Ethiopia, Eritrea, and Djibouti. This area marks a significant point of convergence. Here, three major tectonic plates meet, interacting in a complex dance of geological forces. These are the Nubian, Somali, and Arabian plates, each playing a crucial role in shaping this landscape. They are slowly pulling away from each other, driven by forces deep within the Earth. This creates a zone of extreme tension, a place where the Earth's crust is under immense stress. The Red Sea and Gulf of Aden, located nearby, are already considered infant oceans, steadily growing wider over geological time. They represent areas where the Arabian plate has been actively drifting away from the African continent. This separation has been ongoing for millions of years, a testament to the slow but powerful forces of plate tectonics. The East African Rift is the third arm of this complex geological junction. It's a vast system of valleys and faults extending south through Ethiopia and Kenya, a visible scar on the African landscape. The Afar region is essentially the epicenter of Africa's ongoing breakup, the focal point of immense geological activity. It's a place where the Earth's crust is stretched so thin that it's beginning to fail, showing signs of imminent separation. Consequently, the landscape is riddled with faults, cracks, and fractures, a testament to the powerful forces at play. You'll find fissures and active volcanoes like Erta Ale scattered across the region. Erta Ale offers a mesmerizing window directly into the molten rock far below the surface. In certain areas, the ground has even sunk below sea level, a dramatic indication of the geological processes at work. This subsidence is a clear sign of the crust thinning and weakening under the immense pressure. As the crust thins and weakens, the hot mantle, usually far beneath our feet, rises closer and closer to the surface. This upwelling of the mantle is accelerating the entire breakup process, pushing the continent towards its eventual division. For scientists, the Afar region is an unparalleled natural laboratory. It provides a unique opportunity to witness firsthand the transition from a continental rift to full-blown oceanic spreading. The geological processes unfolding here closely mirror how the Atlantic Ocean originally formed millions of years ago. It's a real-time replay of the events that occurred when the supercontinent Pangaea broke apart, reshaping the world. By meticulously studying earthquakes, ground deformation, and volcanic rocks, researchers are carefully chronicling the birth of a brand new ocean, a process that will ultimately reshape the African continent. The Afar Triangle is more than just a geological curiosity. It's where the future of Africa's geography is actively being written, one earthquake, one volcanic eruption at a time. The drama on the surface, the cracks and volcanoes, begins deep within the Earth's mantle. Scientists long suspected a plume of superheated rock was rising beneath East Africa, pushing the continent apart. Seismometers, like ultrasounds for the planet, revealed the truth. A massive, tilted channel of hot rock, the African superplume, rising from deep within the mantle. This superplume is the ultimate source of the heat and magma tearing Africa apart. It's a river of fire, feeding the entire East African rift system. The rifting isn't just a surface process, it's driven by the planet's deep convection cycles. The superplume pulses, sending bursts of hot material upward, pooling beneath the crust. These pulses trigger major rifting events like the dramatic fissure in 2005. When a pulse arrives, it injects molten rock into the crust, forcing the plates apart. We're not just watching a continent break, we're watching the planet breathe. The rhythm of creation and destruction is set by pulses of heat from Earth's core. The East African Rift is a window into the planet's inner workings. It's a reminder that Earth's surface is shaped by forces deep below. How does a crack in the desert become an ocean? It's a slow transformation. It starts with the stretching and thinning of continental crust, forming a rift valley. Rivers and lakes fill these low areas, early signs of a future seaway. As stretching continues, the crust ruptures and hot mantle material wells up. This magma forms new, denser oceanic crust, marking the birth of a nascent ocean basin. The Red Sea is a real-world example. A young ocean formed as Arabia split from Africa. The East African Rift is a Red Sea in the making. As the Somali Plate pulls away, the rift will widen and deepen. Eventually, waters from the Red Sea and Gulf of Aden will flood in, creating a new sea. Volcanoes will erupt along a mid-ocean ridge, pushing the continents apart. What was once Africa will become two landmasses separated by a new ocean. When the process is complete, Africa's map will be transformed. A new continent, the Somali Plate, will break away, including Somalia, Eritrea, Djibouti, and parts of Ethiopia, Kenya, Tanzania, and Mozambique. These nations will find themselves on the shore of a brand new ocean. The Great Rift Valley will become the ocean floor. The Nubian Plate will form Africa's larger remnant. Countries now deep inland could one day have coastlines. This upheaval will reshape landscapes, climates, and human history, creating new opportunities and challenges. The new ocean will connect the Gulf of Aden to the Indian Ocean, forming a long, narrow sea. Its birth will alter regional climates and create new marine ecosystems. The rift's path is complex, with branches and possible microcontinents left behind. The final geography is still being written in stone. This continental split unfolds on a timescale that dwarfs human experience. Plates move apart at just millimeters to centimeters per year. We won't see a new ocean in our lifetimes. This is a process millions of years in the making. Yet, studying the East African Rift gives us a window into the forces that shape our world. It helps us understand how supercontinents broke apart, how oceans formed, and how Earth's climate evolved. This knowledge isn't just academic. It informs resource management, disaster preparedness, and our sense of place in the universe. The story of Africa's split is a humbling reminder of our planet's deep, slow rhythms. We are witnessing a crucial chapter in Earth's ongoing evolution. While the final split is far off, rifting has immediate consequences for millions living along the East African Rift. The region faces frequent earthquakes and volcanic eruptions, threatening cities and communities. In 2018, a massive crack split a Kenyan highway, forcing evacuations, a stark reminder of the forces at work. Yet, the rift also brings opportunity. Geothermal energy powers economies, volcanic soils support agriculture, and dramatic landscapes draw tourists. The rift is a double-edged sword, risk and resourcefulness intertwined. For East Africans, living on a continent in motion means adapting to both danger and opportunity. It's a testament to human resilience in the face of planetary change. The story of the rift is one of survival, innovation, and hope. Africa's split is more than a regional story. It's a lesson in Earth's dynamic nature. The continents and oceans are in perpetual transformation. Studying the East African Rift reveals the processes that have shaped our planet for eons. The breakup of continents has altered climates, driven evolution, and shaped life's history. Our understanding has grown through global scientific collaboration, from mapping rifts to imaging mantle plumes. This discovery fills us with wonder and connects us to the cosmos. The same forces that shape stars and galaxies are at work beneath our feet. The story of Africa's split reminds us that we live on a world alive with change. It's a chapter in Earth's epic